Notes 9D. Characteristics of exponential functions. Objective. I can describe exponential functions using formal math vocabulary. Essential question. What can I describe about exponential functions? Please read over this vocabulary. Use it for reference for later. Let's look at this example. We're graphing the equation that we're given. F of x equals 1/2 to the x power. The first thing, let's go ahead and identify some numbers in the table. So when we have x is equal to -2, we'll have 4. To get this table, let's go ahead and graph this in the calculator. To graph, go ahead and press this button with the parabola, and we have f1 of x. So let's go ahead and type in our expression. Parentheses, control divide, 1 down 2, close parentheses, and then press the caret button to the x power, and then enter. So here is our graph. To find the table, we press Control T. So we can fill in our table of values by looking at this. Here's our input, our x values. Here's our output, our y values. So here's our table of values. The y-intercept is when x equals 0. When x is 0, y is 1. So our y-intercept is 0, 1. Let's go ahead and plot that point on the graph. Let's plot some other points. So we have -2, 4, -1, 2, 1, 1/2, and so on. Let's connect these points to make our graph. So the domain, if you look at the left side, the right side, the arrows are going on forever. There's no vertical asymptotes. We're just going to put all real numbers. The horizontal asymptote will be that dashed line that we'll draw that's right below the bottom of our graph. In this case, the horizontal asymptote is at y equals 0. The graph is above the horizontal asymptote, so that means the range is going to be y is greater than 0. If you look at it from left to right, it's going towards the horizontal asymptote, so that is a decay. Looking at this graph, we have f1 of x equals 1/2 to the x minus 2 power. Well, the domain is still all real numbers. And the horizontal asymptote is at y equals 0, just like on the previous one. The graph is above the asymptote, so that means it's greater than. Y is greater than 0. This was also a decay. It's going towards the horizontal asymptote. Now the thing that will change though is the y-intercept. So if we look at our graph, our y-intercept Our y-intercept is when it crosses the y-axis. In this case, it is at 4. So your y-intercept is going to be at 0, 4. So the only thing that this -2 in the exponent affects is the y-intercept. Let's look at this word problem. Electricity is draining from a capacitor. There were originally 350 volts. The volts decreased 10% per hour. Let's do our BHS method. So the first thing we want to do is box the numbers. So we have 350 and we have 10%. So we box the numbers. Step 2, we want to highlight our key words. So the electricity is draining. And they're originally 350 volts. And the volts are decreasing 10% per hour. So we've highlighted our keywords. Okay, the S is for selecting tools. In this case, we want to identify our givens and our unknowns by filling out this box right here. So it says this draining is decreasing. That means that this function is a decay. P is for our original amount, our principal amount, which is 350 volts. The rate R as a decimal would be the 10% per hour, and as a decimal we'd have 0.1. So that's the rate. And it's decreasing, so there's a negative sign in front of it. So let's write our function. A of t equals our principal amount, 350, parentheses, 1 minus 0.1 caret, and then to the t power. In this case, the y-intercept would be the original amount of volts. So that's at 350. So when t is 0 hours, our volts are 350. That's our meaning. The original volts. Your horizontal asymptote is y equals 0. That means that we're approaching 0 volts. And of course we can't have negative volts here. So we're done with that part. So we've written our equation. Let's go ahead and graph it on here. So our y-intercept is 0, 350. So we'll plot a point and call it 350. And we know that it is decaying, so when we draw our graph, it'll be something like this. On this problem right here, it just wants you to write the equation. It's not asking for something specifically. A patient is given a 300 milligram dose of medicine that degrades by 25% every hour. Let's go ahead and box the numbers. We have 300 and 25%. And let's now highlight the important words. So we're talking about milligrams. And it degrades. That means it decreases. And it's every hour. So it degrades. That means it's decay, not growth. P is for the principal amount. That's 300 milligrams. R as a decimal, we have 25%. Remember to change it to a decimal. We move that decimal place over to the left 2 times. Let's go ahead and write our equation. We have A of t equals our principal amount, 300, parentheses, 1 minus 0.25 since it's a decay, caret to the t power. Our y-intercept would be when time is 0 at the initial time that this is being measured, when the patient is first given the dose. It's 300 milligrams. So basically the meaning of this would be the amount of milligrams when the patient is first given the medicine. The horizontal asymptote is y equals 0. We can't have negative amount of medicine. So it is the medicine approaching 0. So let's graph this. So we have 300 at the beginning. And it's a decay function. So it will look kind of like this.